Yeah, hi, good evening, everyone. Welcome to the second session for week 3. So, I hope you all have watched the videos and you have done the questions. So, this week basically most of the things are related to the that hardware related, so electronics related things. So, do you have any specific query in the week 3? Otherwise, I have another plan for today's session. Actually, I wanted to just give some demo on the real hardware on that STM.
No doubt, sir.
Okay, okay, fine. Okay, so actually, today I'm planning to just give demo on the real that microcontroller of the STM32. So I have basically two microcontroller. First is that STM32 NIC Clio, that G474RE model. Another is that STM32 F407G Discovery model. So that actually Discovery model basically I have connected through my computer, and that there is some problem in the cable of that another Nucleo board actually. So I am turning on my camera so you can see also the hardware. So that another ID have actually joined. Okay, so that Atul PS you can see. So you can see the hardware on that. Okay, I've joined from two IDs today. Okay, so this is actually let me just show you. This is STM32, the Discovery board. Okay, so that model is F407G. Okay, and another model I have this in Nucleo, but some cable issue is there. So actually, I'll just give demo on this Discovery board. This is also a STM32. So you know that we have that STM Cube IDE for this STM uh, microcontroller programming. So that I'm opening that. One second. Let me share my screen also. So as you have already seen that LED turn on, turn off, okay, and that blinking and in turn on based on the input. So that type similar code actually I want to explain today, but in the form of that C language, okay, not the Arduino language. So let me open the editor. One second. So you can install this Cube IDE from the st.com website, and it is freely available. So I'm launching this. One second. I hope my screen is visible.
Yes, sir.
Okay. So this is actually that STM Cube IDE you can see on the top. Okay. And here actually how we can start, how we can write the code. So you can simply type the C program code inside the main C, but how we can create the project first. Okay. So you have to go inside the file. Okay, file, and inside this, because we want to write the code on the hardware. Okay, so that microcontroller, physical microcontroller. So how we can create a new project for this? So this is file new. Inside the new, we will select this new, and one second, this is still in opening phase. Just wait for, okay, to 1 minute. So some progress is still running. So on the right side, you can see some progress is still working. Yeah, it is done. Okay, so now we will click on the file. Okay, so this is simply a editor where we can write the code, and this is very heavy rich actually editor. So you can also access the memory and that hardware memory. You can also debug your code on the hardware, and you can also access the registers of the hardware. Okay, so there are lots of feature this actually IDE contains. So today we will just write a very basic code to just blink the LED. Okay, so new inside the new, and just create the STM32 project. Okay, so this is the third option from the top, STM32 project. When we click on this, okay, so now new that tab is opened actually. So here actually we select the board. So it asks to select the board first. So either you can directly select the board by the code number, or you can also click on the board selector. So let me click on the board selector. After that, you have to select the board. So any board if you have, then you can select that board. Okay, so I have this discovery board. So this is, you can see there are lots of models are there in this list. So STM32, that disk 0. So let me just reach this STM32 F4. Okay, so STM HGF. Okay, F4 and 07G, 07 disk 1. Yeah, this model actually I have. So which is I'm selecting now. So STM32 407G disk 1. So when I click on this, you can see the board is coming on the lower side. So that board list one item is only coming in this, and inside this I'll click on this board. Okay, and when you click on this board, you can also download the document related to this. So as like this reference manual, user manual, you can download this type of documents related to this board. Okay, so all boards are that resource are available. And after that, you can click on the next. So when we click on the next, it asks for the project name. So we can give any name for the project here. So like I'm giving the name like Blink, okay, LED, and on discovery board. So DISC test one. Okay, so that name I'm giving. This directory of the session name already exists. Okay, test 10 2. Okay, so I've given the name of the project. After that, just target language. This is C. We will write the code in C, and this binary type executable, that is also fine. And here targeted project type. So we will click on the empty. Okay, so we will write the code from the scratch. And when we select on the this first option, so it will actually provide some by default code and setting that it will create automatically some file. So we are clicking on this empty file. Okay, and after that we will click on the finish. Okay, so it will create one new folder. So you can see on the left tab. Okay, so here new file is created, this blink LED dash test 2. Okay, and this is the project which we have created. Inside this, there are many related files is automatically created. Some startup code is created, but we need to enter inside this src source. Okay, and inside this there is one main.c. So this is the file where we need to write the code. Okay, when we click on this, double click on this, you can see this is the file open, and some comment information is there. So that is related to the IDE. So we can remove this. Okay, and also we can make comment. This is also not related to us, so that some line we are making comment. Okay, so if you remember that we have learned about this stdint.h. So this is related to the data types actually which we used for some that cross compiler issue. So we use the data types from this library. So here we can assign the data type based on the size, what size we actually need. So that size will be allocated for every platform. If we used any compiler or any IDE, so that will remain same. That will not depends on the hardware. So this is uh, stdint. So if you are allocating 8 byte or that 4 byte, so that will remain same on the every compiler. Okay, otherwise what happen if we are using the normal standard int or that sort or double, so it may be changed on the different compiler or different hardware that we are using, we can use for the microcontroller. Okay, so because this is hardware dependent. So this is library we will use to declare the data type or size, that like int or something that we will use. Okay, and this is the by default main code. It is that main function we it is generated, and inside this there is one for loop. So for loop is basically to run the code infinitely, so that actually code will run continuously in the microcontroller, and microcontroller will work accordingly. Or we can also write the code, but that will work only one times. But if we want to just write a code for the blinking led, so that should be performed continuously, that operation should be performed continuously. So generally we use this loop forever. Okay, so we can also use the while loop instead of this for loop. So this is just a infinite loop condition that we can also make comment right now. And this is the part where we can write the code. Okay, and how we can build the code and how we can upload the code on the hardware. So that I have not written anything. Okay, in this let me just remove this comment and just, okay, keep this. Okay, suppose this is the basic code we have, and we don't have any code. So how we can build the code, how we can compile the code, and how we can run the code. So for build the code, just click on this project file, and right click on this, and there is one option build project. Okay, so build project, when you click on this build project, it build actually, and it generate a that elf file. So this .elf file, this is actually a file which we uploaded on the microcontroller. Okay, and this is basically a code or data that contains all other instructions or code which we have write here into some another form, that binary form, and that is actually uploaded on the microcontroller, and the microcontroller run this code. Okay, so this is now right now we have built, this is not uploaded on the hardware right now. And what we will do for uploading the hardware, so we what we can do, we can click on the same project, right click, and we can run edge. Okay, so we can click on this run as, or we can also click on this debug as. So debug means we can debug the code, we can check the memory or all the things we can check related to the hardware, that memory addresses, registered address, that we can do everything. So suppose if we can click on this debug as. Okay, so and first time maybe you have to configure that debug configuration, but this is already configured now. There's no setting actually where when some screen is actually open like this, you have to just click on this all next like this. Okay, so here this is now created, already created. So what you can do, so what file we have created right now, so that is actually blink. Okay, that is not coming here. Okay, let me launch 1 second. Okay, let me run again. This is asking first time when I'm clicking on this edit launch configuration. Yeah, so some setting we need to do. So this is okay. So main is fine. Debugger that is also okay. And startup code, source code, you can just keep as it is, nothing to do here. So like click on okay. Okay, now you can see on the board one light is actually blinking. Okay, so that means that code is actually uploading on the hardware. Okay, so this is indicator from the board. One light actually blink, that red and green. So this code is now uploaded on the hardware, but you can see nothing is reflecting on the board because our code is not doing anything. Okay, so this is just simply a, yeah. Someone is asking anything. I just
Yeah, hello.
yes, yes.
So I do have one physical board with me, STM nuclear board. I
Mhm.
wanted to understand for ST-Link connection, do you need to do some setup in this IDE, or we can connect directly and use that?
You can correct that directly when actually when you create the project, just select this like file and new project, and inside this you have to create stm project, and then you have to select that your board.
Okay, understand. Yeah.
Okay, yeah.
So it will detect automatically for
It will
debugging.
detect automatically. Maybe sometimes it will ask some that driver upload or something, so you can just upload that.
So this driver will come with the IDE IQ. Now when I
It,
download
yeah,
it,
it comes by default, but maybe sometime if it is not recognized, then it will maybe ask some
okay.
maybe update, some package update, like this type of things, maybe that ask.
And this .elf and the binary and hex file. I mean, what is the major difference? I mean, you told that ELF file will be created, then you have to debug. Some
That
cases,
that file is actually basically that created for the hardware. That
okay,
.elf, this is the extension for the file which actually uploaded on the hardware.
so it is called hex file also, or how
Yeah,
it is?
it is also called hex file, or
Okay, okay.
yeah. Okay, so now it is uploaded. Code is uploaded on the that hardware. Or you can see this message last in download verified successfully. Okay, and then setting down, but nothing is happening by the code. So how we can do something through the code? So that we will write. Okay, so and we have another some very nice feature from this IDE. You can also check the memory locations. So like I'm writing something in the code, that simple code. Okay, so this is not very. So this is the area where we can declare the global variable. Okay, so I am declare one global variable, declaring one string. Okay, actually at int a equal to 10. So this is global variable. Okay, and I'm writing some const. Sorry. This is basically some program. Okay, so int z equal to that x plus y. Okay, so how we can access the memory things, how we can check the memory area, because in the every that microcontroller we have two specific memory. One is flash memory, another is data memory, that is called as a SRAM or RAM, main memory. Okay, so flash memory basically is a that non-volatile memory. That means if we can remove the power from the microcontroller, your code will remain in the code or that memory. Okay, it will not delete. But that data memory, that main memory, is actually a volatile memory. So that data will be removed if you remove the power. So that flash memory and that uh, these things, how we can check what is the starting address, or what is the another registers also is there. Okay, so we have the different registers for the microprocessor and another for peripherals. Each have actually their own registers, so that we can also check. So let's build this. So this is also fine. Okay, there is no error in this code. It is showing some warning. Okay, unused variable. Okay, no problem. Yeah. Okay, after that, when we click on this and we click on this debug, and debug, after that stm this one. Okay, So now this time, we have opened this project in debug mode. Okay, so inside the debug mode, we can just check the code step by step. So you can see now our code is stopped at this point. So this is one breakpoint. You can see on the left in this bar, and our code is stopped now this point. And on the right side, there is some that another tab is actually open: variable, breakpoint, expression, disassembly. This is also one nice feature of this IDE. You can also see the assembly language code for this. Okay, so the how this code is actually converted into the assembly language code. So you can see the instructions. Okay, so like our code is stopped at this point, so some marking is there, I think. Let me check. Yeah, you can see in the assembly language code, every instruction is actually converted into the assembly language code. So here you can see this int x equal to 10. If these tabs are not visible to you, how you can open this? You can simply go in this window, and inside this window, and you can go inside this show view. Okay, and inside this show view you can see this many features like this, uh, that disassembly. Okay, so this disassembly is there. Okay, and similarly expression is there, memory browser, that that registers, and this sfrs, this is also a peripheral registers. And these stuff you can just trace the things. Okay, you can debug the things with the help of these many features, that breakpoint or these things. Okay, so all these are opened like in my tab, because I have already used this before, so because of that these are opened by default. Otherwise, if you are using first time, so you can see all these view from this window and show view. You can just click on this, whatever you required. Okay, so this disassembly, you can see our breakpoint is now this x int x equal to 10. And what is the corresponding assembly code is generated for that, that you can see. Okay, so this left side, this green area, this 08001 ICE, this is actually a instruction code for this. Okay, so every actually we are, when we pass this code compile code to the compiler, that is actually converted into the assembly code, and that our processor is actually execute all the instructions. Okay, and instruction is identified by some instruction code. So that is this is the code actually we have, this 8001 CE. And what is the meaning of that code is move, what is the assembly language instruction is that movs. This is actually the instruction set of that processor which we are using for this ARM processor, that for ST. So that processor related instructions are there. And what operation is there? So here x equal to 10, so this 10 value, some registers is assigned for this. So this is R3, this is the register, and that 10 value is moves to R3. After that another operation is performed, this is stored something. So these are the assembly code is generated corresponding to this our C code. Okay, and we can also move step by step from this above point. So step into that step over this feature. So like step into, if we move to the next step, you can see the control is also moving to the that assembly language also. This is also shift to the next instruction. If someone is have any query, you can just open your voice. Yeah.
So shall I ask?
Yes, just ask, because I am not able to see the
So
that
the
meeting.
green numbers are basically as opcodes on the
Yeah,
right.
opcode. Yes, correct. That is opcode. And another things, these are operands basically.
So this address is with respect to the microcontroller number, or it is with the or CPU where the program is, I mean the computer where it is run.
What things this?
No. Yeah, this green whatever address is written.
This is
This is
this is not an address. This is a code actually.
okay. So it is. I mean, okay. Then okay, understand. Yeah, I thought this is some address. Okay.
or you can also see here when we click on the variable. Okay, so this type of expression list is open where all details are given, like this you can see that details, that what is the value of that location, or we can also see expression. Okay, this is under that variable.
I think, sir, the green part of code is a low-level language. I think the processor will execute this code.
Yeah, this is the code actually which a processor is actually execute. Okay, so
Yeah.
this is the conversion of high level language to the machine level language. So this disassembly is basically assembly language. So that assembly language is called as a low level language, machine level language we can say. So this is the code. You can just if you want to just debug the code in on deeper level, then you can also check from this disassembly. You can just check the things, how the code is actually converting, how the movement is happening. So then you can also check. Okay, and registers are also you can see, so that this list you can see, this is general registers we have. So what is the, this is the name of the general registers, this is the very long list. Okay, and another is variables. So some memory, let's open one second. So view and SI. This is not there. Back is there. Okay, binary after.
Sir, without a
Selection.
code, we can't see these things. Sir.
That's it. Browser, one second. Yeah, stopping the code. Let terminate. One second. Again, I'm opening the debugging mode. Okay, so some place actually we can see the address also of these variables, but it is not visible. Breakpoint expression. Registers. Okay, let me run this. This is different things. Okay, so these are the things actually we can also debug. So I'm not going into much detail because this ID contain lots of feature. Okay, but today actually we are planning to just give the demo of LED blinking light. But you can explore these things. Okay, so this is just a feature of the IDE. So you can explore this window and how you can show the memory things, so view, so that you can just explore. Okay.
Yeah, I think let us focus on the register and configuring the LED.
That things. Okay. Okay. So this is startup code. Let me make this. Okay.
Sir, do we
So
need the board, sir, actually, to work with this IDE?
yes. So for this IDE, you need board actually. Otherwise, you have to work on the Walkv platform. So that we have actually suggested. If you don't have the board, then you can write the code on Walkv. Okay.
Okay, sir.
So related to the code things, suppose we want to just turn on the LED. So by default, this board is actually provide some LED, user LED, that we can use to turn on or off. Okay, so that we can see from the manual. So that we have some manual here. So this is the reference manual, which is actually important for this. So this is STM 32F405. Okay, so this F4 series all comes under this. So similarly, we have user manual for discovery boards. So you can see this board. So this is the board where we have this pins, and that is different, the complete details. And another is this is data brief. This is also, and this is the schematic structure for this. Okay, so in this structure, in this reference documents, you can see the details about some pins and these things. So here actually we have some port that we can use as a GPIO, that general purpose input output. So there are multiple ports actually this board's provided. So this is like you can see here on this, that one port is a port, and we have this 0 to 15 pin. Okay, so this is port A, and P means port, and that B is just a name of the port, and after that pin number. So this PB and this PC, you can see this range, and each pin we have on the board. If you see the diagram of the board, so you can see this. Okay, so you can see on the left or right this PC0, PC1. So this C means C mode. Okay, similarly we have B also in this list, and we have that A also, E also. Okay, so this is called as A, and another side you can see D also. So all these are actually mode, that port. Okay, which we have, and which we can use for the general GPIOS and another purpose. And you can see in this diagram, if you move down, so some LEDs are already available on the board itself. Okay, so this you can see this last diagram, LEDs. Okay, this LEDs is already connected on the pin, that port D 12 pin. Okay, and another that port 13, and this 14, 15. So 12 to 15 LEDs already connected with different colors. Okay, so green, orange, red, blue. So this is already available on the board, and you can use these pin to indicate something, or just as a user purpose. Okay, so first thing, we want to blink, we want to just turn on this LED. So you should know which actually port you want to use. So that is actually D. Okay, so that port D. Okay, and we have this 4 pin. So you can use any of the pin to just turn on, or you can also turn on all pin. Okay, so this 12, 13, 14, 15. So we can note down this in some place. So like we have the D, port D. Okay, and where the pin is like that 12, 13, 14, and 15. So this port D, and this pin we want to just use as a turn on or off. Okay, so this details we have from here. Other details, how we can identify that memory address, because we want to access all the things by the memory address. Okay, so this is the document reference manual we can use for the memory mapping. Okay, so here you can, in the table of content, you can just explore the things. So inside the memory and bus architecture. Okay, so this is the point you can jump, and memory map. Okay, so this memory map, when you click on this memory map, you can see the range of the all part of the memory, and where the all things are used, and what is the starting address, and what is the boundary address for that last address. Okay, so here you can see peripherals inside the second column. So these are the things which are connected to the processor, and you can use for some purpose. So GPIO is also comes under the peripheral, and that you can figure out. So you can see GPIO. Okay, so here from this GPIO, you can see these are the GPIO we have, and we want to access the D, port D, so that GPIO D. Okay, so this GPIO D, general purpose input output D port. Okay, so that we want to use, and what is the starting address for this GPIO we have, you can see from this table. Okay, so this is the starting and end address, so that you can note down this. So what is the GPIO port address for this? So that I'm noting down this. Okay, so this is the range. So let me size. Okay. Okay, so this is the starting address. Just remember this. So 400, and this is in hexadecimal. Okay, and for the memory, you can see the all details like this, where it is started on the very long list we have. So yeah, so this is the starting address. You can see this is starting from this address, and this is going to the above. Okay, so all the address it is going like here. Okay, so this address actually we note down. After that, another thing is, because that by default this STM, that GPIOs, that all are actually disabled, that are not enabled in the microcontroller board. You have to enable these, and you have to also enable the that clock for these, so that you have to enable the clock for these mode to activate these. Otherwise, by default, these are in disabled mode. So where from we can check the clock, because every peripheral has their own that registers. Okay, so that actually access the registers value, and based on that they perform the actions. So actually we want to find out the address of each control. So you can see the that RCC. Okay, in the same port GPIO, that which we want to access, and another is we want to enable the clock for this board, so that RCC we have. Okay, so the AHV1, and this is the actually bus, which bus all these peripherals are connected. So this is the detail AHV1. We have the different bus also, APB2, like this, but this GPIO-D and this RCC all are connected to this AHV1 bus. So then we will check the address for RCC, and you can also go to the RCC detail. Let me first note down this. To activate the mode, that port, we have to enable the clock first. Okay, so this is the another address range we have for the RCC, and you can go in the details. So what is the RCC, and okay, okay, so let's, this is the memory things. After that, yeah, the set and clock control. Okay, so this is the RCC, and before that we have GPIOs also. So let me check what the address we need to update for the GPIOs. So let's check where is the GPIO address random. Okay, just stop me if you found GPIO term on this menu, or let me search into F, that GPIO. Oh, there are lots of.
No, go to the content. It will be there in the first page. No?
Yeah, GPIO, that 8 point. Okay, yeah. So this GPIO you can see here, and inside this, just go to the GPIO registers. Okay, and this is the part you need to check. Okay, so this is the GPIO registers we have, and this GPIO port have multiple registers. So I think 10 registers are there for GPIO, and each have some specific purpose. So you can see GPIO port mode register. So this is port mode, and after that port output type. So which actually how we want to use that port actually. Okay, so this is mode 5. Okay, GPIO address offset is 0. That is fine. Okay, so you can see these are the value for the modes. Okay, so each registers have 32 bit. Okay, so 0 to 32 bits. And in these bits, each two bits actually representing the enable or disable information. So you can see the value, what are the possible value for this each combination of two bits. Okay, so that is actually 0 0. If we set this, you can see 0 to 1. So 0 or 1 bit is representing to mode register R0. Okay, so that R0 and mode that one pin and like this. Okay, so in this way all pins are representing.
So
So
which pin number like one will be where? I mean, zero
yeah,
and
so
one will
suppose
be.
if you want to enable the pin like this 12 number. Okay, so this is for the first LED. Okay, yeah, so we will use this mode 12 to enable this. And how we want to use this pin? We want to use this pin as a that output mode. Okay, we want to
Zero one.
pass, yeah, we want to pass the output for this. Okay, we are not reading the input, we are just giving the output, and we want to turn on the LED. So that means we have to set the value 0 1 for this place. Okay, so mode 12. If you want to enable that 13, so if you have to place the 0 1 for this 27 and 26 bit. So in this manner you have to set this bit. And if you remember, we have already discussed this set and reset these things by the help of this bitwise operator in week 2. Okay, so that things we can use here to enable the or disable things. So first thing is just identify the that registers for this. So what is the register? And offset, you can see this is the starting address, and which is representing the mode register. Okay, so what is the starting register? Okay, so okay, let's move to the what is starting register we have note down for this GPIO address. So this is the this one. Okay, C1. So this address is basically representing the mode register, that GPIO mode registers. So that we can use in our code. So that first I am writing the code that mode enable. Okay, so I am writing the code address for mode enable. So like port mode enable. So enable for purpose, what is the starting address we have? This one. Okay. So after that, each actually registers you can add 4 byte. Okay, 4 byte means 32 bits means 4 byte. Okay, so you can just directly move to the second type of registers by adding the 4 byte value in the base address of this GPIO address. So this is for the mode control. We want to use that pin as a output pin. Okay, after that, second things. Uh, this is the another registers we have. So this is output type registers, no need to do anything for this. So how you can reach this? So in the base address, just add this 04. You will reach at this address. Okay, and you can use the value for that. So same, this is the next port output speed registers. This is also not useful. This is the that offset address for the, okay, so in the base address just add this value and you will reach at this address. So this is pull down, this pull up, this is also you can use if you want. And that, yeah, GPIO port input data registers, so that we are not reading the data, so this is also not required. And next is you can see GPIO port output data registers. Okay, so here actually we want to use as a output that pin, so this registers is required. So you need to add this 14 in the base address of the registers. Okay, so in this pin you can see we want to pass the output, and we have total how many pin? Total 16 pin, 0 to 15. So you can see in the 32 bits only the first 16 bit are actually enabled, and remaining 30, that 16 bits are actually reserved, not useful. Okay, so what you need to do, you need to just pass the one value on this place. If you want to turn on the LED, that 12 number bit, that, okay, 12 number pin, you want to just pass the high signal. So you have to just place the one value at this place, this position. Okay, so that will be actually read, that pin will become high in the high state, and your LED will turn on. Okay, so we will just note down the address. So this is the offset value for this output. If you want to use the pin as an input, so you have to go this address. Okay, you have to jump this address. This is port input data register, and you have to enable read or write some. You can read the value from this pin, this locations. Okay, this address, this location. But here we want to just give the input, give the output value. So we will use this registers for the GPIO, that port D. Okay, so what is the starting address? We note down this. So this is 14. This is hexadecimal. So we will add this 14 in the base address for this. Okay, so that means for data. Okay, so data output address is, so just add 14 in this base address. Okay, so this is the base address, and you can just write this and plus and x0, that 14 you want to add. Okay, so this 14 will add 0 x into 0 x into 14. Yeah, so this 14 will add into this, so this will become like a, you have already done this type of calculation in the questions. So this 0x, and after that the base, this 4002 and 0c and 14. Okay, so this will become a address of the output registers. Okay, so we want to change, so this 4002, okay, this is fine, and this is 0c G14. Yeah, this is correct. Okay, so this is data output registers, we found that. So now we have noted down this first thing, this one, port mode enable registers address. Okay, and these two address are important, and another address we need to find out the enable, that clock. Okay, so that we also find which is the clock we need to enable. So we have to move the RCC, that reset clock control. Okay, okay, so this, there are two reset control for STM30F43. Okay, so this is the second one. Okay, second one we have to move. So because our board is 07, so we just check this and RCC registers. Okay, and for register you can see, so this is the offset register, this offset address. So that means base address we will add this value 00. After that, let me check. Let's define this. Okay, what is the base address we have? Okay, 23800. Okay, so port D, actually we have to check where is the port D. RCC PLC. So we have to figure out RCC GPIO. Okay, so RCC clock config register is different, and clock interrupt register, and then AHV1 peripheral. Okay, yeah. So GPIO G D. Okay, so you can see inside this RCC AHV1. So this is our all that peripherals are connected. This that port D is connected through this bus, this AHV1 peripheral reset register, and here we have the this is the address offset. This is RSVAB. Let me check another
So
also.
that is third bit, I think it was.
Okay, let me check another also. AHV1.
In that table it was there, I think, port D and
Okay,
port A.
yeah.
In that table, if you see, the third one was port D. Here.
Okay, so that is RCC AHV1. Okay, and here so you have to check this bit 32, 21 DMA, and the GPIO, GPIO H and GPIO D. This one. Okay, so bit 3 is actually representing the GPIO D. And for 0, if you pass the 0 way, that means does not reset IO, and reset IO port D. So 1.
So you have to configure to 1 for reset. Huh?
Yes, you have to configure 1 for this.
And for the clock frequency also you can change for the port D.
No, this is actually for port D. No, this is we are just enabling the clock.
No, that's what I'm asking. Suppose there is frequency given by the system, I want to change that as
No,
well.
that is not required. This is by default that clock that we have to
Okay.
just enable this. So here this is the address offset, and we have to add this in the base address. So what is the base address for this? This one RCC clock. This is the base address 3800. I am confusing this one second. Control. I'm missing something. Third bit. So that was okay. GPID. So this bit we have to set 1. Remaining will be 0. So let me just use this. So address offset is 10, and 10 we will add in the base address. So that will become the RCC clock address. And this is the base address. And plus 10, so it will become 3800. So it will become 10. Correct? So yeah, this is now become RCC clock address. Okay, so we have the address, we have the address of all registers now, and we have to enable all the things in the code. And I have some doubt in this, so let me check the things. RCC general purpose. Okay, RCC clock. This. Okay, so I think this is the same. Reset clock. Okay, let me check. RCC register. Okay, 1 second. RCC register, and inside this CHE1. Oh, I think we are doing wrong. So this is the actually clock which we need to enable. This RCC AHE1 peripheral clock. Okay, so that was not peripheral clock. Okay, so this we need to actually update. So you can see inside this we have the same type of GPIO, because our GPIO is peripheral. Okay, so that we need to check. So only the offset address is different. Otherwise, all things are same. So you can see offset address is 30 for this RCC AHP1 peripheral clock enable register. So this clock enable, we need to enable the clock for peripheral. So we will add the offset address here 30. Now this is the address for enable the RCC clock for the that enable the port. Okay. Now these 3 address we have. So these are the required things to enable the things on the board. So let's write the code now. So that this is the IDE. Okay. So first things, we will create the pointer. Okay. So we are actually accessing the address directly. Okay. So what we will do, we will create some variable. So I am removing these normal variable, and here we will create some variable. So we will use that stdi int. Okay, so we have this unint not underscore 32 underscore t. So this is the way to create the pointer, that variable. Okay, so that integer type, uninteger type. So T, and we want to create a pointer because we want to store the address directly. So that we will create a pointer. So first pointer we want to store for the clock. Okay, clock control. So like we are giving the name like clock control. Okay, and we want to pass the address for this pointer. Okay, so what is the address for clock? This is this one. And inside this IDE, we will pass this address. So, but we cannot pass in this way. Okay, so we have to define to the compiler that this is an address. Okay, so we have to typecast this. So we have to typecast this value before this. So we will use the typecast for the same data. So you, I think this is uint. Uint 32 underscore t. Yeah. So this is the way to create a pointer for each register. Okay, so we are creating the pointer for registers. So now first address we have assigned for the first variable. Similarly, we will assign uint 32, and another register we will enable mode. Okay, so that port enable mode. So that underscore t, and this is also a pointer. So enable mode. So same, what is the address for enable mode? So that is this one. Okay, okay, same things we will do. We will use the typecast for this, and this is the column. Okay, now this is second, and last we will assign for the output register. So that data output. Okay, so three registers we are using here. So that the address of data register is this one. Okay, now this is the three pointer we have assigned. Now we have the reference of each address locations. Now what is our next goal is, first things we want to enable our clock. Okay, so to enable our clock, what we need to do, just go to the clock address. So third bit. Okay, so this GPI or D in enable. Okay, so this enable we want to set this one. Okay, so what is the current value we have for this address? We want to set 1 here. Okay, so what you can do, you can use OR operator. And for third place, if you want to set this location to 1, so what should be the mask for this? Okay, so what operation we will perform here? We will perform we want to update this address, and we want to enable the clock. So to enable the clock, just, so what is the address of clock? This one. Okay, so we will use this. So we are updating the value at this address. So we will use this equal to, and what equal to, we want to perform some bitwise operator to set here. So we will perform, if you remember that, to set some bit, we can use this OR operator. So this is the OR operator. Okay, and which bit we want to set? We want to set the that 0 1 2 3 third. Okay, so that means what is the mask value for this? So that should be 8. If you are not understanding that, so that means if we have something 32 bit, like, okay, so this is 32 bit, like, and we have all 0. Okay, so this is 0 bit, 1 2 3 4 5 6, like this. Okay, so we have this all bits, 32 bits value set to 0, and we want to enable this bit to 1. So what should be our mask for this? So our mask should be like this. So 0 1 0 0 0, and all value will remain 0. Okay, so these are the current state of the value of the register, and this is our mask, and we will perform OR operation on with this two value. And after performing OR operation, this will become 0. So 0 0 0 0 0 0, and 0 1 will become 1. Okay, and all will remain same. So you can use this mask. And what is this value actually in the decimal form? 1000. This is 8. Correct? If you remember, this is 7, and after that 1000 will become 8. So we can perform the OR operation or bitwise operation with 8 value. So that we can do in the here. So just write like this. So 8. So this is the one update. We have set the uh, enable value for the clock for port D. Okay, so now this bit will become 1, and our clock will enable for this port D. Okay, so this is first step. After that, next step is enable mode. We have to enable mode in output mode. Okay, so this is the second place we need to update. Okay, and how we can update this? We want to enable the mode into the output form. So just go to that same location, the GPIO, and that GPIO registers, and inside the GPIO register you can see which bit we need to set here. So we want to enable our this pin in output mode. So this is the general purpose output mode. So we want to enable this 12 pin in output mode. So that means 25 and 24. This bit should become that 01. Okay. So this is the task, and 01 is called as a 1. We can say 1. So how much? Okay. So same things we want to set this. So that means this bit should be set to 1. Okay. This 24th bit, and this will remain 0. So 0 and 1. This is the task we have, and how you can do this. So one thing you can figure out that what is the decimal equivalent value for this location. If you just put this 25 0 and all bits before that 0, and what is the equivalent value. So you can open one that binary to decimal. Okay, so binary, or you can use also shift. Okay, left shift, right shift, binary to decimal. Okay, so here binary number. So initially we have total 32 bits. Okay, so like 0 0 0 0 0 0 1 2 3 4 5 6 7 8, and 8 4 times. Okay, so now these are 32 bits we have, and we want to enable that which bit. So let me check. So that is second ID data registers. Okay, this one. So this is the 24. Okay, so 1 2 3 4 5 6 7 8. Okay, this bit we want to set to 1, and this should also be set to 0. Okay, so this should also be set to 0. So how we can do this? So 1 2 3 4 5 6 7, and 8 from the right. So let's move to this. 1 2 3 4 5 6 7 8. This should be 1. Okay, and convert this into a, so this is coming as a decimal form. So this is very tough calculation. What other things we can do? We can use the that 1 is 24 0 1. That's left shift or right shift we can do. Okay, so for left shift, if you remember the operation of left shift or right shift, so what is the meaning of that? So left shift means if we have any number, okay, so like 0 0 uh, like or we can say that if we have any number 0001, okay, and we want to perform left shift 2, so this one will be shifted to this point, okay, so 0100, this will become like, okay, like this. So this is, you can do these things in this way. So you can shift the first bit to the 24th location, so you can write like this. So you can 1 and write like 24. Okay, so 1 is representing this 0000 like this, all 32 bit initially, and this is the 1 bit, and this 24 will, this bit will be shifted to 24th position, and this will be set. Okay, so that things we can do. But we have also ensured that 25th bit also be set to 0. So how we can ensure that? Okay, 10 that. Okay, so what we can do? That one enable that things, so that we can, if suppose if we use this or equal to, and we will shift this or equal to like 1, and this left shift 24. So 20, this is 24. So this is 24 bit. Yeah, this will become 1. Okay, and this will remain 0, I think. Okay, reset stated 00. Okay, that 00. So let's try this. Okay, so we have performed this operation. Later we will change this if we are not getting the correct. And another thing is we have performed things, and another thing is data output. So next step is, so this is done, and last is data output. This value should be updated to high mode, and this is also and or. So for enable this bit into the high mode, so that same things we will perform. And what is the data registers we have? This 6th register, the port input data register and output data register. So this 12th pin, okay, so this 12th pin we need to perform in the high mode. So this 12, that means we need to shift 12 onto the left. Same things we can do with the shift operator. So that is okay, sorry, 1 and left that 12. Okay, and these things we will write on inside the, so that our light should be turned on, so that we will write like while, inside the while condition while, and inside this while. Okay, and we are removing this. Okay, so now this is the code, and let me check this, build this and see what is happening. So build project. Why this lots of warning are coming? Initialization of 250. Okay, yeah, some issues there. So the typecasting issues there. Hmm. And let's run the output. Oh, this is not okay. Okay. Yeah, so now this is built, and let's run this on board. Okay. Can you see on the board if it is visible to you that green light is actually turned on? Can you see this, or let me turn off the light? You can see it's on the board near to this processor. One green light is turned on. Okay, and this is LED turn on, and we can turn off. So let me just update this code, and this will become turn off. So you can see the board. Let me go to the D. And how we can this to turn on or turn off? So that things we can also do. So okay, and we can pass some delay here. So how we can pass the delay? And for delay, we can run a loop like this. So for int, sorry, int I, and this is totally a okay C code. I'm not writing any abstraction code here. So this is like 0, and I is less than equal to, and I'm taking some large value like this. Okay, and I plus plus. Okay, and this is the loop we have, and this loop is running. After that, and we will make this turn off. So we will use the another way to do this. So that is AND operator, and this will become AND sign. So we are making that bit with AND operation with the 0. Okay, so how this is working? So first thing what we are doing, we are just setting that 0 0 0 like this, and after that 1, and then remaining 11 bit are 0. But we are inverting this, so we are this is the inverting operation, and it will become all 11, first 11 bit will become 1, and then 0, and remaining will become all that 1, and we are performing AND operation with this. Okay, so AND operation means that bit actually will become 0 after performing AND operation with 0. Okay, for that location, and remaining will remain same with the AND operation with 1. So this operation is basically to turn off the that reset that value to 0, and again we are using the loop. Okay, now this code we are writing here. So this is a while loop, it will run infinitely. After that, we are just setting the bit data output bit to 1, and we are running a some loop for delaying for some time, and after that again we are resetting that mode data output value to 0. Okay, and then again loop. So let's build this again. Now this is error, so I think something is missed. What is missed? We have made so while, oh, inside this while loop. 1 second.
Sir, maybe it's because of that gap between the left shift.
Where?
On line 27 and 22, maybe because of that.
No, there is
Sorry,
no
on 29, sir. Sorry, on 29.
this one. So this is not a left shift. This is a loop.
Yes, sir. Maybe that space after
No,
the.
this error is coming due to some expected that one is missing. Let me check. So some bracket is missing actually. So this is while loop starting here. Two while loop is there. 1 second. So this while loop is starting. Then for bracket is closed now. The another for is closed now, and this is the termination. Okay. Then we remove this. Okay. So let's run. Build this. Now this is successfully compiled, and then run this on the board. So that run is STM32. So now you can see on the board light is blinking. That means a code is uploading on the board. Yeah. So after that you can see on the board this green light is now blinking. Okay. So if you want to change the LED, so just change the that address you have to just change. Okay. So 20 for suppose we want to enable that uh, 13 pin. Okay, so just change the address of this. So what is the 13 bit is, we will check in the map. So this for 13 we have to enable this bit. Okay, so 13 here. Okay, so this is the one change, that one change we can do in the code. So instead of 12 we will write 13 here. Okay, so this 13 here, also 13, this is the one. And another for enable mode. Okay, so that we have also changed for to enable this, which pin we want to enable. So let's check the address bit for that. So GPU mode pin. Okay, that port mode register. Yeah, so for 13 you have to enable this pin for this, sorry, this one. Okay, 26. Okay, 26 pin you have to enable. So 26, that's this. But we have to ensure that the remaining bit should be 0. Okay, so that we will perform the same things. We will use the invert thing, and this and end sign. This will work or not. Okay, let me check this in the same without doing it. 26. Build project. Okay, and run project. Now you can see the LED color is changed. Now this is the 13th bit LED, orange color. Okay, so now we have changed the pin. Okay, so this is the way to write the code in C language. Okay, so this is not a that Arduino code. This is totally C code, and where we are directly accessing the memory addresses for the microcontroller, and we are updating the values. So similar type you can do with, you can also enable this LED with the help of input. So you can take the input from any pin, and after getting the input high, that your LED should be turned on. So in that case you have to just figure out that which pin you want to make as a input pin. After that you have to figure out the address for that, and you have to enable that pin into the that input mode. Okay, so for the same registers here, so the GPIO port mode register, you have to make that pin for the input. Okay, so that input is state like 00. This is output mode, and you have to read the data of from this registers. Okay, so this second, this GPIO port input data register, you have to use the address by this offset, and you have to read the data from this pin. You can make any pin as input, and you can read the data from that pin directly. Okay, so by that you can also write the code. Okay, so yeah, this is the actually way to write the code on the hardware directly using the C. Here there's no abstraction. Okay, so we are writing the code on directly hardware using the C code. Okay, so if you have hardware, you can try this. If not, then just wait for some more weeks. So maybe professor will give some hint how you can write the same C type of code on the walkway. Okay, so because professor will also explain this C type of code after some week. Okay, is it clear how what is the process to access the things? Because here reference manual is actually very important to identify this mapping, address mapping, all these things. So if you have any boards, you can just use the reference manual and you can figure out the address for clocks and that port, all these things. Okay. Yes. Yeah. Please ask if you are raising the hand. Yeah, Adit.
Sir, I have the F446 board and it has 512 kilobyte of flash kilobytes. So will anything change when I do the same thing?
But so which? Sorry, can you repeat your board name? That your board is Discovery or Nucleo? That which one?
F446, sir.
No, this is the last name. So that Discovery is the main model or
No, yeah, sir. It is the Nucleo board,
Nucleo
F446.
board? Okay, okay, okay. Yeah, so yeah, you can do the same things, but you have to use the reference manual for that board. Okay, so maybe some memory mapping is different, that port address is different, that you have to check the reference manual for that board. Okay, but the coding you can do the in the same way.
Okay, sir. I'll try and I'll let you know within the next lecture.
Yeah, yeah, sure. Okay. Yeah. Yeah, Vinas.
So actually, I have a Nucleo for F41RE. You previously I'm using actually on another course. So
Okay, yeah,
in
that you can also use. You can see I have this another Nucleo board. So, but actually, I'm not able to connect this due to some cable issue.
sir, actually previously I work in embed open OS. So in my computer is showing like a drive. So can I show?
Drive. Okay, yeah, you can share this, but I'm not able
Okay.
to understand.
So it's showing like the drive.
Yeah.
Only
Okay.
connecting this
Okay. Okay.
Nucleo.
Yeah. Yeah. It shows actually. I think it is also shows for me. So some memory spaces actually that provide na. So that actually it is showing maybe.
And when we check my drivers, so it's showing a ST-Link debug. It's okay,
So
sir?
if you have connected some hardware to your that computer, so if any memory is available for you by the controller, so that actually will show. So there's no problem why you are trying to use this. Do not use this.
Okay.
Okay. Mhm. Okay. Yeah. Any other query? So just explore this. Also use this walk v things. Okay. So same things. If you have hardware, just try on the hardware also.
Sir, I don't have any hardware. If I want to purchase what I'm not sure, sir.
You can purchase on the online platform. There are many platforms it is available, but I
Which
think the
board,
cost, yeah, it is depends on which actually model you want to purchase. So
which one will be efficient for our course, sir?
we are using this walkv, and in walkv we have Nucleo that board, na, so that you can also use the same board. Otherwise, I have this Discovery board. Actually, I purchased many time before, so because of that, This I have. So yeah, you can use the board which actually we are using on the that walk fee or in the lecture.
Nucleo.
That Nucleo.
Okay, sir.
Yeah. Okay.
Sir, actually, the thing is, even when I went to purchase the thing which was shown on in Walkme. So that is actually not available in India. So it has a
Yeah.
lower flash. So I had to buy something with a higher flash. So I had to buy
Yeah,
something.
actually, that I also purchased from
Yeah.
the DigiKey one website. So that is actually come from USA. So that custom charges, all things are applicable on that.
Right, sir. So the one I bought, it is available on Robo for I think it's almost for less than 2,000 rupees. Actually, the one which I bought.
Okay, okay, yeah. Some are available on the Amazon or but they are actually included. They have already included the charge maybe for this shipping charge from the US, from the outside of India. But you can do only if you have no board, you can that experiment on the walkthrough. Okay, so and professor is also trying to just give access of some NEELIT lab, actually electronics lab, where you can access the hardware from uh, that hardware directly from your computer, and you can perform some experiment. So professor actually is trying to do. So maybe after some times you will get some information regarding that. Okay.
Okay, sir.
Okay. Okay. So any query or anything else? Yeah, Vinas.
Sir, I'm previously worked on STM Embed OS. This is a online IDE. And which IDE is better, sir? A QID or Embed OS?
So I'm not aware of this embed OS. So this is online ID or that physical hardware you're talking about?
Is powered by ARM, actually ARM
So
processor
all
manufacturing.
actually that STs all have ARM based that processor. So that is fine. Yeah, for actually here we are planning. We are just learning that embedded C programming and embedded system things.
And
Okay, so
also the seniors also suggest that Keel is a better compiler package available. So
which one?
Keel, Keil, Keel.
Okay, that also I'm not aware of that. Okay, so that things you can explore. So because there are lots of microcontroller, and you can explore later also. But initially, right now, focus on the basics of all the things. Okay. Yeah, Privan. Yeah, Privananjan. Uh, yes.
Hello.
Yes. Yes. Kumar.
See, I should thank you actually for this session, and I am expecting some more session like this in future. So, are
Okay.
you
Okay.
planning for that? Something like that?
Yes, sure, sure, definitely. So if professor have discussed some things related to the coding, that hardware, that definitely we will give demo in the session. Okay. And
Oh.
I'll also planning so some another experiment with the hardware in the coming session. Okay.
And this 1D and 3D lookup, like 2D lookup, those things are also covered. I mean, will get covered in this
1D lookup or 3D?
2D
No, that.
lookup, not 3D, 2D.
So 2D lookup for what?
I mean, suppose sometime data mapping for the sensor we'll be doing, like for motor,
Yeah.
for
So
example.
based on the topics, what topics are covered into the in the lecture. So based on that, we will decide. Okay. So what experiment we can.
Okay.
So.
And if suppose we have some doubt, we can put on discourse this kind of doubt.
I'm not sure. So that hardware related to, yeah, you can post on that. So maybe some, if anyone know that, then they will reply.
You have something where you can reach you directly, possible to reach you directly.
You can directly, you can use my email ID that atul@study.iitm.
1 minute. Can you please post it here? I'll copy it immediately.
Or you can use the that discourse forum also. Okay, so that is also for course. So you can write, post anything. So I'm
Yeah,
writing. So
yeah, just can I just post it here? I mean, really thank you that you've taken this kind of session. I was expecting this to happen actually.
Okay, okay, yes, yeah.
Yeah.
Coming week, I think we will definitely perform this type of session. Maybe on walk we also, and I'll also try on the hardware.
Yeah, yeah. Thank you.
Okay. Okay.
Excuse me, sir.
Yeah.
Since I mean, most of us, many of us will have these hardware boards. So I would like to suggest is that we can have some sort of a jam session where we come together and turn on our cameras and demonstrate what we did using our own hardware. So maybe if it is possible, then we can do that. Right? It's a nice idea.
Definitely, this is very good idea. If you are doing something on the hardware and you want to explain in the session, so definitely we can plan some additional session and you can give some demo to others. Yeah, that is very good. Good.
Yes, thank you, sir. So, also, and will in the future will we also be using sensors and sensor data using these boards?
Yeah, so on actually walkwe definitely we will use some sensors, but yeah, physical we will check. So what sensors we have and we can arrange to show you.
Okay, sir. So it's really interesting. So can't wait to do that, sir.
Okay, okay, yes, yeah.
Sir, if I buy that Nucleo board, it will cover the whole portion, sir. I can.
Whole portion means the main concepts of the embedded system, and maybe if you are purchasing something and your board doesn't have some advanced features, so later you will find out that your board is not sufficient for all things. So one board is not sufficient for all purpose, so later maybe you have to purchase more boards to explore another things. Okay, but for basic thing, for basic purpose you can purchase. Okay, so this basic boards Nucleo, that basic. Okay, otherwise very advanced board is also comes in the market that supports many high feature, compatibility to that touch screen, all these things type of.
Okay, sir.
Okay.
Okay, sir. Thank you for a wonderful session, sir. Looking
Okay,
forward
okay,
to
yeah.
the next one also.
Okay, sure, sure.
Thank you, sir.
Yeah.
Thank you, sir.
Thanks, everyone. Yeah. Good night.